Welcome to subtopic 9.2, Redox Equations. Remember, this is the second of 5 subtopics in the Redox chapter. First, let's learn how to write redox half reactions. Here's our example whole reaction, zinc reacting with copper. First, we need to write in our oxidation numbers for every atom in the equation. We can see that zinc is being oxidized because its oxidation number is increasing, meaning it's losing electrons, while copper is being reduced. It is gaining electrons. So now we can start writing our half reactions. Zinc is losing 2 electrons, while copper is gaining 2 electrons. Finally, we cancel out anything that's on both sides of the half reactions, in this case the electrons, and again we have our whole reaction, which is just where we started. Now let's go the other way. Let's try to write a full redox equation using half reactions along the way. Here's an example problem from our book. Take note of our reactants, nitrate and copper, and our products, nitrous oxide and copper 2+ ion. Also, this reaction is specified to happen in acidic solution. That'll be important later. Step 1. First we need to assign oxidation numbers. We write the general equation without any balancing, and we assign our oxidation numbers. We can see that copper is being oxidized while nitrate is being reduced. Step 2. Now we can start writing half reactions. This step is actually multi-part. First, we need a balance for atoms other than oxygen and hydrogen. So here we have our copper going to copper 2+, and our nitrate ion changing into nitrous oxide. Copper is balanced in the first half reaction, and nitrogen is balanced in the second half reaction. Again, at this point we're ignoring oxygen or hydrogen. Step 2b. Now we need a balance for the oxygen by adding water. We can do this because, remember, this is all happening in acidic solution, which means we have plenty of water available in solution. So let's balance the oxygen in the second half reaction by adding some water to the right-hand side. And we can see that we have 3 atoms of oxygen on the left and 3 atoms of oxygen on the right. Step 2c. Now we need a balance for the hydrogen. And now, again, because this is occurring in an acidic solution, we have plenty of hydrogen ions available to us. So here we've added 4 hydrogen ions to the left side of the second half reaction. We have 4 hydrogens on the left and 4 hydrogen atoms on the right. Step 2d. Now we need a balance for charge, and now we just add electrons. We're not actually pulling in electrons from the solution, this is actually just theoretical. Finally, step 3. Now we need to equalize the electrons in both half reactions by multiplying as needed. So we'll take the copper half reaction and multiply by 3, and the nitrogen, or the nitrate half reaction, multiply by 2. And here's our result. You can see that both half reactions deal with 6 electrons. That leads us to step 4, our final step. We can add our half reactions and cancel out anything that is the same on both sides. Those electrons we generated are the first thing to go. And now we have a complete oxidation-reduction reaction that is balanced both for atoms and for electrical charge. Now you can see why we made up those theoretical electrons that didn't really exist. We needed them in order to create this fully balanced redox reaction. That's it. Thank you for watching.